So now let me just quickly go and implement the little bit complicated part on the sets, that is ordered set. So currently we have implemented sets. So these are the unique collection, but these are not ordered. But the ordered set that Redis provides is quite complicated. So we will understand this. Let me just show this. I hope you guys are able to see this. Let me just create another page over here. We are going to implement ordered set over here. Ordered sets. So as I told in the starting of video, think of these ordered set as a leaderboard. So you must have seen a leaderboard, right? So we have a leaderboard of users. Let's say we are like making something sports related. So we have a leaderboard of users, and these users have a specific score attached to them that ranks them in order, right? So as soon as the scores updates, these users or these players, let's say P1, P2, P3 and P4, they reorder themselves, right? So this score help us to reorder these players according to their rank, and it identifies their rank according to that score. So we will store the values, and these values are ranked according to the score, right? So we will use a B tree set for it and a hash map for a key, and we will implement all our functions. So now let's figure out what all things we need to implement. We will implement something called ZADD and ZREM and ZRANGE. And few things to note over here is we are going to use B tree set. So what it does is it will automatically based on the score, it will automatically arrange the items available, and this hash map will store a key linked to this B tree set. So we will implement ZADD, ZREM and ZRANGE, and the score that we'll use here, we will use a floating point number f64. But a catch over here is f64 doesn't implement a total order, like, so we will also implement these traits as well, ord and partial eq traits. So this floating point f64 it doesn't implement the total order, so we need something called ordered float crate, something like that. We need to install it, and we'll take help of this to implement this total order traits for f64, and later we can parse it to f64 while fetching it. We will implement these things like ord traits and partial eq trait. We'll create a struct called members, where we will link it with the hash map and store these members. All right, so let's go on to the code base and let's quickly implement these things. So basically these three things we will implement, that is ZADD, ZREM and ZRANGE, right? So let's quickly lay out few things, let how we will implement these B tree sets and all. So let's go on to the data structure files that we have created and start working. I think we are here. Yeah. So let's implement sorted sets or ordered sets over here. So as I told, we need to install a crate over here called ordered float. So we'll do cargo add ordered float. Exit this. You know what, let's do a build. Okay, exit this. All right, now let's create a struct called members. So we will store our sorted members over here. We'll have a member over here that will be a string, and we will have a score over here. And the score will be f64, but it will be, sorry, f64, but it will be wrapped on ordered float, right? So we'll do ordered float, and we need to implement some macros over here. Let me just do it. We'll do something like clone and eq. Alright, so it says partial eq is not implemented. Yes, we will implement it, but first let's name it sorted members. Alright, so what we are going to do, we are going to implement partial eq for sorted members, and it missing a function eq, right? We'll implement that. So let's implement this function eq over here. So let's say pub function eq, and we have and self and other as self. It will return a bool, and it says self dot score equals other dot score, and self dot member equals other dot member. Okay, visibility. Okay, so that's, yeah. All right, now implement another trait, as I told earlier that we will implement ORD and partial EQ trait. So let's implement this thing, ORD for sorted members. So what we'll do over here is we will first check with the scores, and if these are not equal, then we will, if these are equals, then we will check with the members, right? These member names, that the string that we have. So let's create this function. We have self and other, self, it will return an ordering, of course, ordering. And what it does is it says self dot score, right? And so first we will check with the score. If the scores is equal, then we will check with the members, right? So we will say other dot, what it takes, it takes a reference, ordered float reference, right? So we will do and it takes a ordered float. So currently we have score as an ordered float, so other dot score, and we'll unwrap, or so a default ordering that we need to pass returns a contains some value, or so, but for now we need to return out the default ordering, and the default ordering is ordering dot equal. And then we'll do, if this equal, then we will check by the members string value, right? The members name for now, let's say. So what we'll do is we will say self dot member dot cmp other dot member. We'll do something this. All right, it says partial order is not implemented. Yes, we are going to implement it. We'll say impl partial ordering for sorted members, and we will do partial cmp. So we have self and other as this. It will return an ordering. So what we can do over here is we'll do something over here that says self dot cmp and other, right? So we have implemented partial order as well, so partial eq, ord and partial ord with that we have implemented. Now let's implement a tree set that we are going to link it with this sorted member. Now let's go ahead and create a struct for this. We'll say r sorted set, and we'll create a member that will be of type hash map, and it will take string, and of course this ordered float, that is f64, and another value that is sorted, and we'll use b-tree set for that, b-tree set, and we'll store these sorted members in this. So this sorted set has the score, and that score is already available in this sorted member, right? So this key has a score on the hash map on these members variable, and this member variable basically is a hash map that has a key, and the value of that key is the score of that sorted members that is already available on this reset. So we can do a lookup from that, and we can add find range and remove based on this thing, right? So now that we have implemented this thing, now let's implement these functions that we have told that it will implement. Let me just do this thing first. impl or sorted set. So we'll implement something called ZADD, ZREM, ZRANGE. All right, so let's do this thing. So we'll simply do pub fnu, and it will return self. So what it does is it will return our sorted set, and it has members that will be a hash map new, and sorted that will be b-tree set new. All right, let's implement zadd over here. Function zadd, it will take a score that is f64 and a member that is of type string. It will return a bool. So now what this zadd does is So as I told earlier that imagine this as a leaderboard. So as soon as the score gets updated, the ranks will also get updated and the members will automatically order themselves inside this B tree. So the reason of using B tree set is that it will, as soon as the score updates, it will automatically orders itself, right? So that is why this ZADD function, it takes a score from the input, because it will check whether the it will first of all fetch the member's old score. Then if it's an old score, it will simply delete that member and re-add that member according to this new score. So it will automatically get ordered in this B tree set. So let's quickly do that. First of all, we need to do is we need to parse this f64 into ordered float crate that we have implemented, right? So let's do that. So we'll say let ordered score, that is ordered float. Inside this we'll pass our score. All right, now we need to perform our checks like this. So as you can see, the score is the input in this function, right? So we will check whether the score that is coming as an input is same as the old score. So if both the scores are same, then we'll do nothing. We'll simply return false. This bool value will be false. And if there is a change in score, then we need to delete that node from this, and we need to recreate a new entry, and we will insert it inside this sorted struct parameter, and it will automatically reorder itself. So for that, we need to first of all fetch the node from this sorted set. We'll do is if let some, we will have a old value over here, old score, let's say, and we'll do self dot members dot get. What it does, it needs a ordered float score, right? So a reference of member. So as soon as we receive, so first of all we need to check whether if the old score equals the ordered score, then if it's the same, then we'll do nothing and return false. But if it's the score has been changed, we need to delete this thing, right? So self dot sorted dot remove, it takes a sorted members reference. So we'll do sorted members, we'll have member, right? And we'll do score as old score. So okay, now that we did something like old score, okay, we need to make this. All right, what's this found here? All right, yeah. So after that, if there is a change in the score, we have already deleted this node from this sorted tree set, and now we need to create a new entry, right? So let and reinsert it. Let new entry will be sorted members. We have a member, and we will use ordered score as a score. And yeah, ordered score as a score. Let's do one thing. Clone. Let's do this thing over here as well. All right, it says found bool and all right. So yeah, we have removed this thing. We'll do something now. Now we need to insert it on the sorted reset. So what we'll do is we'll take let's say in, so there are things, right? So this sorted has this sorted members as well, right? So first of all we need to insert on sorted members, and then this new entry will be inserted on this thing, right? And this score will be added as a value of in this members. So there will be two insertion, one on the reset and another on the hash map with the updated score. So let's say, let's call it inserted, let's say self dot sorted dot insert, that is a new entry, and another entry will be on the hash map. So we'll say self dot members dot insert. We will use member as a key because it's a string and we are taking a key as a string, and the value will be ordered, that new score, right? And it's a boolean, so we will return inserted from here. All right, it says this thing, so let's do this. Okay, yeah, this thing, let's remove this. Okay, so it says let's this as well. All right, so this ZADD function has been implemented. Let me just quickly go what we did. We are fetching the score. So the input will take a score, and we'll map it first whether the old score is equals to the new score inserted from the terminal. So if these both are same, that we do not need to order themselves, like, so the rank of that node will be there, like it will not get altered. So we'll simply return false. We cannot add it because the score is same. And if the score is not same, what we'll do is we will firstly remove this member from that reset, and later create a new entry with that updated score and insert it on the hash map over here and on this reset. So we are doing two insertions over here. Let's implement ZREM. Okay, let's say pub fn ZREM. So it will do there, it will also return a member and will return a bool value. So we'll do something like if let some score equal to self dot members dot remove member. So we'll have to remove from the hash map and the ordered set as well. So we'll do self dot let's alter this case first. We'll return false, and after everything is okay, we'll return true. Now let's implement the things in between. So we'll use self dot sorted dot remove. It takes a sorted member, right? So we'll do sorted members. We'll have member and we'll have member and we'll have a score as well, right? So score, let's do this thing. Okay, it says this and found a string. All right, so this ZREM has also been implemented. What we did was, based on the member, we removed from the hash map, and if there is no item available for that, we'll simply return false, and if the item is available, we'll also remove from the reset. So we already have the member and we already have the score that we get from the while removing the hash map, right? The item from the hash map. All right, now let's implement ZRange and Z. So we will have and mute self. We will have start, that is of type usize, and of type usize, and it will return a vector of string. So what it does is it will iterate on the reset and will try to get the members available on that reset. So what we do is we'll do self dot sorted dot iterate. We'll simply follow what we did for sets. We'll do start and we'll take only end minus start plus 1, and this way we will we can map. So we have a sorted member over here, right? So we can do sorted. So we have sorted member over here. So what we'll do is we'll do sorted member dot clone and we'll simply collect those. All right, what it says, it cannot have. Okay, so sorted member, right? We must have member inside it. All right, yeah, so we have ZRange as well. Now what if we need to find the score? Let's say we can implement this as well. So let's say pub fn ZSCORE. So what if we want to fetch the score of a member? So we'll do member string and it will return it's a score that will be of f64. So what it does is self dot members dot get member dot we will have score over here. Okay, let's do this thing. All right, so these all functions has been implemented, that is ZADD, ZRemove, ZRange and ZSCORE. Now that we have implemented this data structure and implemented this function over here, now we need to modify our command parser as well. So let's start implementing our command parser. We'll say we'll implement ordered set over here, right? Let's do this. So let's say ZADD, and what ZADD does is it will have a score and a member, right? So first of all, we need to ordered score. We need to parse our score in f64. So score dot parse, right, dot map error. So we have we'll say invalid score value, right? And we'll do let added equal to db dot ZADD. I cannot get this. Okay, let's go inside db. We need to do this as well, right? Let's say sorted set. So let me just copy this thing, sorted sets, and we need to implement this thing, sorted set is copy this thing. All right, let's go over here now and we can sure that we are ZADD. No, still not. score dot parse. All right, so we need to implement this on the database file as well. We can go over here and say sorted sets. We'll implement these things over here. Async fn zadd, and it takes, so yeah, so let me just copy this and we'll update it for ZREM as well. ZREM. So let this key has found string. So let me just do, we need to pass this thing over here, string, right? It says expected this. So let me just do this. Will that help? Yeah. So we do not need any score over here. So let's remove this thing. All right. Now let's implement ZRange. So it will take and self. So this function has been implemented, ZRange. Now let's implement ZSCORE. All right. So as you can see, we have implemented these features over here from the database file, that is ZADD, ZREM, ZRange and ZSCORE. Now let's quickly modify our command parser that we were doing earlier. Let me uncomment it. We'll be able to now see the ZADD function. Awesome. So we have a key, a score, and a member. Let's do this. Let's do this. So we cannot find key on this score, so we'll quickly use some key. We can do toString. Yes, toString. In the same way, we are going to implement all these three functions that are remaining, that is ZREM, ZRange and ZSCORE. Let's start implementing these functions. So here let me just do one thing. It says in expected reference string, right? So expected reference ZRange. All right, we can say it string, and we'll quickly do this. All right, the same thing we'll pass to every key wherever we are finding any error. We'll do this. We have member. Let's see how it goes. It takes a string, but we have this thing over here, so we'll do toString. All right, so I think we are good. So as you can see, we have modified our command parser as well. So we have ZADD, ZREM, ZRange and ZSCORE function. Let's quickly build this file. All right. We'll do cargo run and clear this thing. We'll say, all right, we are here. So we are going to test our this sorted set part. So let me just quickly go and use this command from here. So we have ZADD, so we'll do ZADD, and what it takes is, it takes a score, a member and a key, right? So let's say we have score 6, now of member, let's say Vipin has a score 6, and the key is my set, my sorted set. All right, so it has been added. Now let's again add this thing, ZADD. Now let's do one thing, right? So now that let me add just few more things over here. To Yoshi, my sorted set. So as you can see, I have added 2 members to this sorted set with this key, right? Let me add another. So will perform it like a leaderboard. So you can see there are 3 ranks. So Vipin has 6, Joshi has 2, and one user, let's say Lord, it has rank 1, and it will go against the same key. Right now what will happen is, let's say Vipin has an update in rank and it goes, let's say Joshi, let's do that, this thing. So we'll say we'll again add, right? So we'll do ZADD, we'll update the score of Joshi from 2 to, let's say 4, and what does it takes is, it takes a member, right? So we'll do Joshi. So ZADD for Joshi, score, a member and a key as well. So my sorted set. All right, so what does it do? It will check whether the score has been updated or not. As the score is updated, it will delete this this node with rank 2 from the tree set and insert this new one, and it will order again. So the rank will again goes from 1 4 6, right? If I do this now, let's fetch the score, right? So Z score, so Z score, a key, that is my sorted set, and the member. So as you can see, the score has been updated. As you can see, it's coming 4. Earlier it was 2. Right now let's do one thing. Now let's remove this thing. Right, so as you can see, the score has been updated, and we have added this score with the updated value. So it means the score has been updated and it is working fine. Now let's find the range as well. So let's do z range. So z range, and it takes a key, that is my sorted set, and start, let's say 0 to 3. So as you can see, Lord, Joshi and Vipin, so these are the 3 members that are on the sorted set. So 4, 5, 5, as you can see their length, and the length of the items on the set is 3. Now let's remove, let's say we'll perform ZREM, and we'll say a key, that is my sorted set, and a member. Let's remove Joshi, and now let's again fetch Z range. Right, so let's copy this thing, and so Joshi should not be there, right? So it will be Lord and Vipin right now. So as you can see, Lord and Vipin. So as you can see, these all the commands that we have created are working fine. So that's it. We have implemented like really good stuff over here. We have implemented list, sets, and ordered set over here, and how we took help of vecdq available from this collections, standard collections, to implement list, and hash sets to implement sets, and a special thing called sorted sets or ordered set. We took help of tree set and hash map to achieve these functionalities that Redis has. So if you guys want to check out my code, I will push it on the Git repo, and the link will be the same that I posted on the earlier video, but I will again post it on the description, and you guys can contribute. Feel free to comment and give suggestion on this video. Alright, see you on the next one. Bye bye.